Solving 3A, undoing division to solve for the unknown. Here are the triads. In 3A, we're solving for the unknown, and it might have something attached to it by division. According to PEMDAS, packages, exponents, multiply, divide, add, subtract. We're looking at things that are attached by division. The partner of division that undoes it is multiplication. So to undo something attached by division, we'll multiply it to the other side of the equal sign. Add and subtract was handled in lesson 2. Number 1, here's my unknown x. 5 is attached by division. To move it, I move it by multiplication to the other side of the equal sign. X equals 10. Why does that work? If I have x over 5 equals 2, and I want to get the x alone, and alone means with like a coefficient of 1 in front of it. If I multiply it by 5, I have to multiply the other side by 5 because equal says everything stays the same on both sides. 5x over 5. The 5's go away and I get 1x. They go away to result in a 1. 2 times 5 is 10. So because we're working on the process rather than why everything and trying to write it all out, which a lot of times leads to errors, I'm just going to say it's attached by division, move it by multiplication. And that's how we're going to go through them. Number 2, x over 11 equals 4. 11's attached by division, move it by multiplication to the other side of the equal sign. And that division goes away because we undid it. X equals 44. Number 3, x over 7 equals 8. Here's my x. 7 is attached by division. Move it by multiplication to the other side of the equal sign, and it undoes the division. And I get x equals 56. Remember, 5, 6, 7, 8. 7 times 8 is 56. Number 4, x over 8 equals 7. Here's my unknown. 8 is attached by division, move it by multiplication to the other side of the equal sign. That undoes the division, and I get x equals 56 again. 5, 6, 7, 8. Number 5, 1 equals x over 9. Here's my unknown, and it doesn't matter which side of the equal sign I'm on. I just want to get it alone. 9 is attached by division, move it by multiplication to the other side of the equal sign. And I get 9 equals x. Now, in the previous video, every time we moved to subtraction, it had to follow. But remember, addition and multiplication are commutative. And that means, like for instance, 7 times 8 equals 56. 8 times 7 equals 56. 7 plus 8 equals 15. 8 plus 7 equals 15. These are called commutative. Let's see if I can spell that right. Commutative. Not so with subtraction and division. If I said 10 minus 3, that equals 7. If I said 3 minus 10, that equals negative 7. Not commutative. Same with division. If I said 56 divided by 7, that would equal 8. But if I said 7 divided by 56, that would equal, this is going to give me 7 times 8. The 7's reduced to 1. That's 1/8. These are not commutative. Okay, let's get back to it. That's why moving the multiplication to the front is totally okay. And it looks nicer on the page. I have 9 equals x over 1. I want to get the x alone. 1's attached by division. Move it by multiplication to the other side of the equal sign. 1 times 9 is 9. 9 equals x. Number 7, 0 equals x over 5. Here's my unknown. 5's attached by division. Move it by multiplication to the other side of the equal sign. 5 times 0 is 0. X equals 0. Number 8, 15 equals x over 0. No, you cannot divide by 0. It's not possible, so you cannot do this one. Let's say I had this group of dots. And I'm going to make 8 here. If I want to divide it by 4, here's a set of 4, here's a set of 4. I would get 2. So 8 divided by 4 is 2. Let's say I wanted to divide it into groups of 0. How many groups of 0 could I get? Well, here's a group of 0, here's a group of 0, here's a group of 0, but what am I doing with these guys? These are leftovers. So division by 0, it can't happen. We can't imagine it. Do you get infinity? But what do you do with the remainders? So division by 0 doesn't happen. Moving on to these triads. Number 1, x over 3 equals 11. I want to get the x alone. The 3 is attached by division, move it by multiplication to the other side of the equal sign. That undoes the division. I get x equals 33. Number 2, x over 11 equals 3. I want to get the x alone. 11 is attached by division, move it by multiplication to the other side of the equal sign, and I get x equals 33. Number 3, x over 7 equals 6. I want to get the x alone. 7 is attached by division, move it by multiplication to the other side of the equal sign, and I'm getting x equals 42. Number 4, x over 6 equals 7. I want to get x alone. 6 is attached by division, move it by multiplication to the other side of the equal sign to undo it, and I'm getting x equals 42. All done. Number 5, 2 equals x over 8. I want to get the x alone. The 8 is attached by division, so I'm going to move it by multiplication to the other side of the equal sign. 8 times 2 is 16. Number 6, 8 equals x over 2. I want to get the x alone. 2 is attached by division, move it by multiplication to the other side of the equal sign. Whoops, 16 equals x. So really, once the unknown's alone, if I don't want to do the arithmetic, I don't have to. This is solved. This is done according to our rules. Number 7, 0 equals x over 23. I want to get x alone. 23 is attached by division. Move it by multiplication to the other side of the equal sign. 23 times 0 is 0. 0 equals x. Number 8, 14 equals x divided by 0. You can't divide by 0. This cannot be done. It's impossible. So I do reviews 1, 2, 3, and 4 for lesson 3A. Make sure you have paper and pencil with you and do the problems, then watch me do them. If you get one wrong, cross it out and start again. Just replace the wrong memory with the right memory. Thanks for being here. Have a great day.